divisibility rules part 1. So we're gonna see divisibility rule of 2 to the power n first. So 2 to the power n means 2 to the power 1, that is 2, 2 to the power 2, 4, 2 to the power 3, 8, 2 to the power 4, 16, and so on. So let's see the divisibility rule of all these numbers, how to find the a general rule for the divisibility rule of all these numbers. So everyone knows the divisibility rule of 2. 2 is the divisibility rule of 2 is like the last digit is divisible by 2, the number will be divisible by 2. Or all the even numbers, like let me write any random numbers. So this is the number. So if last digit of this number is divisible by 2, number will be divisible by 2. Or you can say all the even numbers are divisible by 2. So this is 2 to the power 1. Now let's see the divisibility rule of 4. So divisibility rule of 4 will be 4 has 2 to the power 2. So now what we'll do, it doesn't matter how lengthy, how big a number is, you just need to check this power. I'm telling you a method to remember this thing. So for 4 2 to the power 2, so for 2 to the power 1 you need to check last one digit. So for 2 to the power 2 you need to check last two digit. You need to check last two digit. If last two digit is divisible by 4, then the number will be divisible by 4. So this number is divisible by 4 because last the two digits are divisible by 4. Now this rule you can generalize. So for 2 to the power 3 means for 8. So for the 8, rules become last three digit. If last three digit is divisible by 8, then the number will be divisible by 8. So if 416, this is the last three digit, is divisible by 8, number will be divisible by 8. So this is divisible by 8, that's why number is divisible by 8. Similarly, 2 to the power 4, 2 to the power 5, 2 to the power 6, whatever they are asking, if you can represent that number into 2 to the power, then the power will be the last number of digits. If that are divisible by the given number, then the number will be divisible by the given number, whatever is 2 to the power n. I hope this got clear. So this was the rule for 2 to the power 1, 2 to the power n. Similar rule is for 5 to the power n. Similar rule is for the 5 to the power n. So we know general rule, we know the rule for the 5. Rule for the 5 is if the last digit is divisible by 5, the number will be divisible by 5. Or if the last digit is 0, 5, number will be divisible by 5. So I am just generalizing this rule. So suppose you want to check 5, divisibility rule of 5. So suppose this number is written there. So this number is divisible by 5 because the last number is divisible by 5. Let's write any other number. Let's write any other number that is not divisible. So this number is not divisible by 5 because last digit is not divisible by 5. So what will the rule of 5 to the power 2 means 25? The rule of 25 is that if the last two digit, so let's take this number, if the last two digit is divisible by 25, the number would be divisible by 25, else the number will not be divisible by 25. So here you can see number is not, this last two digit is not divisible by 5, 25 not divisible by 25, 45 is not divisible by 25, that's why this number is not divisible by 25. I hope this got clear. So let's write some other number. So this number, in this number you can see last two digits are divisible by 25, that's why the number is divisible by, this number is divisible by 25. Similarly, it goes for 5 to the power 3, 125, and 5 to the power 4, 1625. So you can generalize this rule for 5 to the power any number. Now let's see the divisibility rule of 3. Generally in the books you will get this rule that if the sum of the digits, is divisible by 3, then the number would be divisible by 3. Generally you get this rule that will be written in the book. So let's understand this. Suppose this is the number 1, 2, 4, 6, 7. This is the number, and if you add the digits of this number, that you'll get 4, 3, 7, 6, 13, 20. So here you can see 20 is not divisible by 3, therefore this number is not divisible by 3. This is a very simple rule. I hope everyone got it. If the sum of the digits is divisible by 3, then the number will be divisible by 3. If sum of the digits is not divisible by 3, number will not be divisible by 3. This is the basic rule. So it's not a difficult, it's simple thing. And let me tell you just a little more convenient thing that you can do. a more convenient thing that you can do, like suppose a big number is written, suppose this, like any random big number is written, suppose this is the number. Now if you add all this number, there may be a chances of error, or maybe like there will be lot of calculation. So in the last class I have told you digital root. I have told you digital root. Now I am changing this rule. In the books you'll get this rule, but what I am telling, remember this rule. If the digital root of number, instead of remembering this rule, remember this: if the digital root of number is divisible by, digital root is divisible by 3, then number will be divisible by 3. Remember this rule instead of the rule that is written in the book. In the book you'll get the rule: if the sum of digits is divisible by 3, then the number will be divisible by 3. But what I am telling, now you know what is digital root, you know how to find faster digital root. So using that technique, if the digital root of the number is divisible by 3, then the number will be divisible by 3. So this is the number. Now we'll use both the method and we'll solve this question. So let's first use the digital root method, and then we'll discuss the sum of the digits also. Then you'll get the like which method is complex and which is easier. So here you can see, let's use the digital root method. So in the digital root method, I have told you how to find the digital root. You will remove the pairs are the 9 है ना, जो 9 पेयर 9 बना रहे हैं या फिर जो number itself 9 है. So you can see this is making 9, so I will remove this number. This pair is also making 9, I will remove. This is also making 9, 4 3 7 2 9, I will remove this. And any other thing that is making 9 or multiple of 9, I will remove. So 5 5 10 8 18, 18 is multiple by 9, so that's why I removed this. So now we are left with only these numbers, that is 14 and 6, that is 20. 20, that is 2 plus 0 2. Digital root of this number is 2. So this digital root 2 is not divisible by 3, that's why this number is not divisible by 3. Clear? If we use the basic method that is written in the book, this method, so we can add these numbers 7 8 15 15 8 15 8 23 15 8 23 23 1 24 24 5, that is 24 5 29 29 6 35 35 8 35 8 43 43 1 44 48 51 53 58 and 58 65. 65 is not divisible by 3, that's why this number is not divisible by 3. So I hope you understand that digital root is easier as compared to the general root that is written in the book. So remember this rule: if the digital root of number, you know how to find the digital root, I have explained in the last class, so use that thing. If the digital root of the number is divisible by 3, then the number will be divisible by 3. Remember this thing. Now let's see the rule of 9. Rule of 9 is also similar. If the digital root of the number is divisible by 9, then the number will be divisible by 9, else number will not be divisible by 9. So let's see. You can note down, if digital root of number is divisible by 9, then number will divisible by 9, else number will not be divisible by 9. I hope this is clear. In the books you will get that if the sum of the digits is divisible by 9, then the number will be divisible by 9. What I am telling, you guys know what is digital root, how to find the digital root, how to faster find the digital root. So you will be using the concept of digital root. Instead of sum of the digits, I am saying if the digital root of the numbers is divisible by 9, then the number will be divisible by 9, else number will not be divisible by 9. Let's take any other example. So let's write some random numbers: 2 4 7 6 9 8 1 2 7 5. So I want to check if this number is divisible by 9 or not. So I will be just using digital root concept. So I will remove this 9. 8 1 9 7 2 9 5 4 9 7 2 9. So digital root of this number is coming 6. 6 is not divisible by 9, hence this number is not divisible by 9. I hope now everyone understand this rule. So this is divisible by 9. Let me just check other numbers like 8, 1, 2, 7, 4, 3, 5, 6. This number. If you want to check if this number is divisible by 9 or not, so you will find the digital root of this number. So digital root of this number will be, that is 639 is remaining. So you can remove this, but digital root will be 9. To remove this confusion, I have taken this example. Digital root of this number will be 9. If suppose all the numbers are getting cancelled, all the pair of 9 are getting cancelled, so final digital root would be 9. I hope you get this clarity if anyone is getting this type of doubt. So digital root of this number will be 9, and 9 is divisible by 9. So that's why this number is divisible by 9. Basically, digital root of number is 9. You can directly say here, if the digital root of a number is 9, then the number will be divisible by 9. Otherwise, number will not be divisible by 9. Simple. If the digital root of a number is 9, then the number will be divisible by 9. Otherwise, number will not be divisible by 9. Now, divisibility rule of 11. Let's understand it with the help of an example. So, let me just take an example 2, 3, 3, 7. So, this is an example. Now, if you want to check if this number is divisible by 11 or not, what you will do? First step is do numbering from right hand side. This is very important. You have to do numbering from right hand side. So on the basis of this, you can see these places are at odd. These are the numbers that are at odd place. These are at even place. These are at even place. Remember this thing, you have to do numbering. You have to like decide the given place is odd or even on the from the right hand side. You will not decide from left hand side. If you decide left hand side, things will become different. So you have to always make sure you have to take care of this thing, that you are deciding this from the right hand side. You like there will be not effect on the answer on the basis of divisibility, but we will be using this same concept in also the remainders. Then it will create the problem. In the remainders, this thing will create problem if you do right hand side or left hand side. So right thing to do is from right hand side. So you will decide the number is at odd or even place from the right hand side, never on the left hand side. Here it will not matter. In just finding out that number is divisible by 11 or not, it will not matter, but it will matter when we'll do the question in the remainders. So remember this thing, you have to decide order, you have to decide the place is even or odd from the right hand side. Now the second step is take the sum of digits at even place and odd place. So sum of digits at odd place, sum of digits at odd place, sum of digits at odd place minus sum of digits at even place. So remember, this will be always remain order. Your order will remain always this odd minus even, not even minus odd. Again, this will not matter here. This will not matter. This will not affect your divisibility rule, but answer will be differ in the remainders. So you'll always have to follow odd minus even. Odd minus even. So here sum of this is at odd is 10 and this is 5. So we're getting 5 and 5 is not divisible by 11. So this number is not divisible by 11. I hope you got important points that I've told. Generally, our questions get wrong in the remainders because of this silly mistake that we do. Odd place, even place. So now you understand this thing. Now let me just tell you a simple thing how to avoid this mistake. How to avoid this mistake. Suppose any random number like is written here. This is number. So what you will do? Always start from this side. Always start from this side. And 8 plus 4, that is 12. And minus it. Always do like this. Just simple. Just follow this pattern. You need to nothing. You need to remember odd minus even or even minus odd. Simple. Start from this term and always put this term first. You have to take that sum that is with this, है ना. तुम्हें वो वाला नंबर लेके सबट्रैक्ट करना है जिसमें ये वाला नंबर इन्वॉल्व हो रहा है. तो 12 is involved with minus it. You will be never get any difficulty. So this is the easiest way to find the thing. You don't need to remember even minus odd, odd even places. Let's do other question also. 7 2 1 4 5. This is the number. So what I will do, 5 4 1 5 1 7, that is 13 minus 6, that is 7. 7 is not divisible by 11, so this number is not divisible by 11. I hope you understand this method. So this way you have to do. You will never do any mistakes. Now the remaining we'll see in the next session.